I'm not, so I can't say it, but there's agricultural limes that are different than masonry limes, okay? And so you want a masonry lime, a lime that's processed in a way for masonry work, not for agriculture or for other purposes. They use lime in all different industries, and so it's not all appropriate. But
They use the lime that we have and mix it with Portland.
right,
So
exactly.
It's lime and a bag of lime and 2 bags of Portland is kind of like a type S water.
Right, so when, depending on how much sand, and so yeah, we'll get into that in a second. But so basically what you have here is this is hydrated lime, which is basically you know, a pure lime that's been burned and then it's you know, pulverized. And actually, so what they do is they actually hydrate it enough to turn it into a powder, and then don't overhydrate it, or it'll turn into a putty, and it'll turn into. And if you go further, you can make a lime paint out of it. And so you can turn a putty into a paint, and it's about a 1-to-5 ratio is the general rule. So if you start with something that's a putty and you want to make a lime wash, what they would call, it's about 1 part putty to about 4 or 5 parts water, and then that just thins it out. But generally a lime paint always had other things in it, that either some oil or some clays or something to give it stickiness and make it have better adhesion. So anyway, so starting from that, so let's see, where can we go from here? So again, to make so this is a modern material, but say it was you know, made in a historic way, you could still turn it into a powder like this. And so, but you would be adding, and we could. I don't know if we should just mix it or just talk about it now. It doesn't really matter. So, but anyway, like about a 1 part, this would be the binder, to about 3 parts sand. So also sands, obviously there's a huge range in sands, and so we'll jump into that subject briefly and talk about sands. And I just have a couple different sands here. And so the coarseness of the sand obviously is a major factor, but also now if we had sieves, we could run it through. There's so many different levels we could just do the theory. You could just talk about sands for a really long time. But let's see. So yeah, this is a much more coarse sand than this. And so this has much bigger aggregates, like actually chunks, almost little chunks of gravel. And so the sand they were using here, actually, that they pulled out of the river, is actually very fine to me. It looks, let me scoop that out. It looks very fine to me, but this is what they said they had to work with. And so, yeah, this is super fine. So it's, other than it has some bigger chunks, but it's pretty fine sand. This is what they were trying to work with here when they were doing work most recently. Doesn't look like the best sand for historic work to me, but you know, this is what they came up with because they got this from some hatchery that was downriver. So this is river sand, they were saying, but it's very fine. It doesn't have a lot of aggregate. It's got some big chunks, but so anyway, but with sand, the finest part of the sand gives you the overall color. As I said, they call that the fines, and the bigger chunks are going to give it the texture to it. You know, like the almost piece of gravel sometime, and that's going to give it the kind of and sometimes the texture, if you will. And sometimes they were using shells, and you'll see that, oyster shells, and you'll see that in some of the historic work, and that incorporated into it. And so the shells that were not completely pulverized. And so also, if you were using shells as instead of a quicklime, then if it was not fully burned, when you actually, you know, slake it and mix it up, if you're making a mortar, there would be some pieces of shell that would not break down completely. And those would turn into aggregate. So those wouldn't actually slake, and then that would, you know, come to the surface, and that would give you texture also. Or to give it a historic look, you could be adding crushed shells to it, which they do a lot now as well. And so anyone have any comments or questions? Because that would be helpful to have some interaction. So about mortars in general, lime mortar, or anything?
You have marble up there? Would you have the marble in with the putties as well?
So this was, I mean, it's a good question. It's not really. So marble is just another aggregate. And so you could make, so the point being that if we were wanting to patch marble, we can add, instead of sand, we can use the marble. And then we can make a composite patching material, or if we're doing work, say, like on a marble structure, like I work on, like, say, I work on a marble mausoleum, and the joints are pure white, and the building is pure marble. And so I can take, and I would be using not a pure, not a, just a hydrated lime like this, but probably an NHL, but we can actually just use this instead of sand and make a mortar out of marble, so that or if we're doing patching, composite patching is a term that we would be doing patching loss as opposed to just filling mortar joints. And we could also make composite patch material to repair brick. And so that's another thing that we didn't really discuss, whereas we have bricks where there's a lot of loss and you know, for whatever reason, inappropriate mortar or whatever. And so there's a few different options depending on the amount of loss and the situation. But another option is we could patch those areas with a composite patching material. And in the case of a brick, what we could do is pulverize brick and make brick dust. And then we could use the brick aggregate as the aggregate, and then use, say, if we use an NHL, what's going to happen is that it's going to lighten it up a little, and then we could use a little bit of pigment to redarken it back toward the brick color. And the idea is to use as least pigment as possible, and ideally, so it kind of jumped subject into composite patching, which is related, but the idea is, ideally, you want to use the same material that you are patching with, but most people don't do that. But if you want to do a higher level work, you want to use like with like. And so if you're doing work on brick, you can actually use the brick to make your repair material. Whereas most composite patch materials made, like something made by Cathedral Stone or Concroco, are just, they may or may not have Portland cement in them, but they have a lot of pigment in them. And so that they're creating the color you're matching usually by using a lot of pigment, and usually those fade badly over time for different reasons. And so, so anyway, that's kind of a related subject. But so you could use any aggregate. That's the important part to understand. So if you're making a mortar, you need a binder and an aggregate, and you can use any aggregate, and you could use granite. You can use crushed granite, and you're going to get a mortar that's made from granite and or a patching material. And I'm not saying you want to do that here, but you can do that, and it'll make a mortar. So. Or a composite patching material, which are related. They're basically similar. I mean, they're almost the same thing. You could add additional components to give them different properties. And so composite patching materials, say like a company like Edison Coating, makes products that they add latex modifiers to give them elasticity, but then also it has the potential to trap moisture. And so that's a whole other related subject, but I'm kind of getting off topic. So, so back to this subject matter where we started. So, so let me just, so we have the lime mortar. So the issues with lime mortar, let's go from that now. It's very slow to cure. And there's a lot of, they said, and Katie said, they had a lot of failures when they tried to use pure lime mortars. And so, like I said, it takes a lot of babysitting. To me, it's not really practical. In most situations, in a historic structure like you're working on, where you have a defined structure and you have, I would imagine, a good budget and highly skilled masons, it is appropriate. But in the field, in most circumstances that don't have that type of stewardship and budget, usually it's not the best option, because it's likely to have failures because there's not enough time to have it cured properly in the first place. So just backing up a little, any historic repointing work, one of the most important things is a moist surface, okay? Other than the preparation, we'll talk about removing mortar from the joint, cleaning out the joints, moist surface is imperative, because the bricks or whatever the masonry units are much more porous, and the mortar behaves differently. And so if you make a mortar the perfect consistency and you put it on a dry brick, what'll happen is it'll draw all the moisture out of the mortar and into the brick, and you'll get what's called a flash cure, and it'll never harden properly. And so no matter how many times you keep misting it after the fact, if the brick is not moist enough to begin with, it's not going to work. And so this is, I mentioned yesterday, they do misting and remisting, and Gerard Lynch was just talking about this in his presentation at the IPTW, how they would, for 2 or 3 days, they would be misting down buildings before they would start repointing them. And then it should never be glistening, it should be damp to touch, and because if you get it moist enough, it'll hold the moisture. The problem is if you just moisten it, it looks moist, but then it evaporates. And so you have to, keep misting it down to get it to hold enough moisture, and then to get a good cure. And then when you mix the mortar, you want it to be very stiff. You want it to be almost like, and we'll mix some. We'll probably just wait till after lunch now. You want it to be very, very, almost like a dry cake mix or something like that. But not. You want it to be. You'll see once we mix it. It has to be pretty stiff. And so then you push it into the joint, and that's the other thing, is that most people want to slick the joint, but you're actually pushing it into the joint. And you're just working down the joint, you keep pushing it in. And so the moisture that's within the brick connects with the mortar that's, that's moist but not soaking wet, and then they all, it fills the joint. And that's the basic process. And then what you do with the joint after is a big effect as well. So, what time is it right now? Give me some kind of idea. What's that? 12, yeah. So, I'll just go a little further and talk about natural hydraulic lime, and then we'll probably stop for lunch, and there's no point in mixing anything right now. So, they bring it full circle, up to speed. So, as a lot of people started to be more sensitive to the historic structure and try to recreate the way things had been done, they started to work with the lime mortars more, and with variable results, and oftentimes not good results, because of the things I mentioned. They're tricky. There's a lot of potential reasons that they fail, and so people started to think about other alternatives. And that's when natural hydraulic limes started to be imported to America. And natural hydraulic limes are, as I had mentioned yesterday, they're basically like this. However, they have other minerals in them that give it some hydraulic action. So they're basically somewhere between a pure lime and a Portland cement. Okay, they're kind of a compromise between the two, if you want a very simple version of what they are. There's 3 different versions of them that are commonly made, and the originally they didn't have numbers. Originally they had words associated with them coming from overseas, and so the weakest version, which is now called an NHL2, was called feebly hydraulic, because it was just a little bit hydraulic. And that's the British term, and of course, if you say it with a British accent, it sounds even better. And so it had a little bit of hydraulic action, but it didn't ever get that hard. And I'm not going to get into the exact numbers. So then the moderate, and then that is what they called it actually. They called it moderately hydraulic, which has become the most popular version of the NHLs, which is the NHL 3.5, which is the mid-range. And the hardest version, which will approach a Portland cement in hardness, is NHL 5, and they called it eminently hydraulic. And so and that means it would get hard more quickly and become harder in the end as well. And as I mentioned yesterday, whether it be Portland cement or, so let's start from the beginning. A lime mortar cures only through carbonation, drawing carbon dioxide back in the air. It has no hydraulic action. A natural hydraulic lime is both. And so it's going to have some hydraulic action, it's still going to carbonate. And so on the low end is the NHL2, on the high end is the 5, meaning that the variable amount of hydraulic action, they're all still going to carbonate. And a Portland cement also carbonates. That's why Portland cement gets harder and harder for a year. It's going to have an initial hardness from the hydraulic action, but it's still going to keep getting harder. And so they all carbonate, and so that's a kind of source of confusion. But the point being that the lime mortar only carbonates. It has no hydraulic action, so it takes forever to harden. And so it's not really a great alternative for production work or for, in practical applications. So the natural hydraulic lime started to be imported to America. At this point now, there's maybe a half a dozen companies that have some presence in America. There's a few that are much more known now. And St. Astier had a pretty large market presence earlier, and it's a great product. It's made in France. And one of the differences and one of the downsides for historic work of the St. Astier is it's extremely white. And so why does that matter? Well, if you're doing historic pointing work, generally you don't want really white joints. You want something that's more buff or more subtle and blends in with the structure more. And so if you're using something that naturally is a very white material, you need to pigment it or do something to tone it down. And so this is one of the downsides, but it's a great material. It's been made, since the mid-1800s, and it's been used on a lot of projects with great success. But that's one of the downsides, and it's interesting because I was just at this event called the IPTW, which is International Preservation Trades Workshops in Frederick, Maryland. We had our event this year. I'm on the board of that group, and we had it at the Historic Preservation Training Center in Frederick, Maryland. And so a guy was over there from Scotland who this guy Chuck Jones, I think, and he was, we were talking, and in fact, we're going to go over there to Scotland next year, next September, and have the event there. It's been planned. But anyway, we were talking, and I was talking with him about, because, he's overseas and what they use over there. And so, and I was thrilled to hear that he says, I like the Atterbahn the most, he says. That's what he told me. He says, I don't like to St. Astier because, he says, it blinds me. He says, it's too white, it's too bright, he says. So he says, it's good, but it's too bright. I asked him, there's another company, the oldest NHL in the world, I'm pretty sure, is called Singleton and Birch. And they're from the 1700s. They've been making the same product. And I considered importing that too, but the price is higher. And so he said, and I thought, it's good. It's been made since the 1700s. He said there's been a lot of failures of that product more recently because of, I don't know, something with the source of the quarrying or the manufacturing process. I don't know why. But so all over the world, there's a lot of NHLs. So there's Spanish ones, and there's not so much in Italy that I know of, but there's a lot of natural hydraulic limes. We didn't really have these in America because of the geology of the rocks. So we had something called natural cement, similar but different, chemically, geologically, and so, but there was a natural cement component in this structure, and I'll just mention that briefly, and the most famous natural cement name and place is Rosendale, from Rosendale, New York, and natural cement is like a natural hydraulic lime, but actually gets harder and gets harder quicker, and it gets hard very quickly. And so it has different mineralization. It's still a process where you quarry it and you have to burn it. However, it doesn't slake at all. It will not slake. And so, but once you mix it with water, it creates a chemical reaction and it has extreme levels of hydraulic action. And so it was a really good material to use for very quick construction, and to use, it will actually harden underwater, and to use it, to build, dams and moats and things like that. It was phenomenal. But the problem with it is that it hardens so quickly, like you try to work with it, and they have some here. We'll get some probably later. They have a barrel of it. I should have brought some. I have one. I have a French natural hydraulic lime, natural cement called Prompt, actually, that I have. I should have brought a bucket of it. But anyway, it hardens like spontaneously. Okay, so it's a problem to work with, because like you mix a batch up and you're like, okay, I'm going to work with it, and it's too late. It's hard. And you can't retemper it. Retempering means you add moisture, you add more water, mix it back up. And with a natural hydraulic lime, you can retemper. With a lime mortar, you can retemper forever. I mean, but with an NHL, you can retemper also to some degree. And in fact, one of the definitions of a natural hydraulic lime, that if you mix up a big batch of it, like a wheelbarrow, like a tub full like that, and so you use half of it, and at the end of the day, you pack the remaining bit down, you mist it down a little, probably best to throw some tarp or something over it, and then you come back the next day and you can just add a little more moisture and work it, and it'll still work because the hydraulic action is very slow. And so the term for that would be to knock it back up. And you can then rework the material, and that is one of the actual defining characteristics of something that is an NHL versus, you know, an NHL 3.5 you can do that to, and even more so a 2, but a 5 you can't do that to because it has more hydraulic action. It'll be too far along. And if you try to retemper it, then it'll never cure properly. So anyway, what they do with the natural cement, and then we'll probably break after that, just mention that. So they add retarders to it to make it so it is workable. And so what they most commonly use is citric acid, and citric acid is used as a food preservative. It's a powder, and it's used for many different things in industry, and you don't need much of it. And a little bit of citric acid will slow the curing down and make it so it's workable. And so, and that's what's commonly done. And if you add, you know, too much, then it'll affect the curing, and it'll, you know, so it's a pretty small amount to a pretty big amount. It has a huge effect on it. And anyway, that's a big overview, a lot of subject matter in a very short amount of time. And so, any comments, questions? I guess not.